Gigafactories, not just electric vehicles, are Tesla's true product. That's how Elon Musk once perfectly summed up Tesla's mission in a single sentence. He said, "We've realized that the true problem, the true difficulty, and where the greatest potential is building the machine that makes the machine." Now, the Tesla Model 2 is the perfect example of that philosophy put into action. Every curve of its exterior, every electrical line underneath, shows just how far Tesla has moved the line between design and manufacturing. The new prototype, being tested on California streets, has strongly confirmed a complete system of AI, gigacasting, and structural integration all working together as one unit. In this video, we'll break down these three key engineering choices that are so important. They will force every other car maker to either change the way they build cars or simply become irrelevant. Stay tuned, and if you want to be among the first 8,240 people closely following this huge change as it happens, make sure to subscribe and turn on the bell. This is the moment Tesla's whole way of thinking finally takes its physical form on four wheels. First, let's talk about the dual-motor architecture. How completely does it get rid of the reliability problems that plague many budget electric vehicles? Looking closely at the Model 2 prototype, the 19-inch wheels and tires are quite wide, between 215 and 235 mm. More importantly, the wheelbase is only about 2.65 meters, which is about 20 centimeters shorter than the Model Y's 2.85 meters. These specific measurements suggest that using only a single motor on the rear axle would have limited how power could be distributed. This strong hint tells us that Tesla likely chose a dual-motor setup for the Model 2. One electric motor is placed on the front axle and another on the rear axle, creating a full-time all-wheel drive system. This configuration pushes the total power output to 400 horsepower, which is about 300 kilowatt, with each motor contributing roughly 200 horsepower, along with a huge instant torque of 350 pound-feet. But here is the critical difference between this setup and what you'd find in a Volkswagen ID.4 or a Hyundai Ioniq 5. Tesla's motors do not need to communicate through mechanical parts. In older all-wheel drive systems, and even many electric ones, there's still a history of compromises inherited from gasoline car designs. You still have reduction gears that need constant oil, differentials that require service visits, and control modules that cause small delays between the front and rear axles. The Model 2's system is much simpler. Each motor works as a totally independent traction unit with a direct digital connection to the central AI computer. There are absolutely no mechanical parts getting in the way. When the system senses a wheel losing grip at the rear, power is shifted instantly in just 8 milliseconds, which is quicker than a tire can finish a single rotation. If you compare that to mechanical all-wheel drive systems where the time it takes to engage can be as long as 150 to 300 milliseconds, you start to understand why. Tesla's method fundamentally changes how a car handles internal technical reports. From Tesla have revealed that the Model 2 prototype can accelerate from 0 to 60 mph in a blindingly fast 4.8 seconds. This is a full 2 to 3 seconds quicker than direct rivals in the same category, like the Chevrolet Bolt EV or the Nissan Leaf. This extra speed makes it easy for the Model 2 to overtake other cars on the highway, spend less time in other cars' blind spots, and reduce the time needed to react in an emergency using torque vectoring. The two motors on the Model 2 also divide power intelligently to each axle. The system uses AI machine learning that is based on Tesla's full self-driving chip, the AI5. This advanced system constantly processes data from hundreds of sensors, including how fast the car is going, the steering angle, how hard the driver is braking, the current road conditions, and even the driver's normal driving style. It uses all this information to decide precisely how to share traction between the two motors and four wheels with up to 99.9% accuracy, instead of just trying to fix a slip problem with the brakes. For example, the motors can send up to 70% of the power to the rear axle when the car is going up a steep hill, or 60% of the power to the outside wheel when taking a corner at 50 mph. This feature significantly improves the Model 2's grip, reducing the chance of wheel spin by 40% in wet or snowy conditions, providing a much greater sense of security for older drivers in areas with severe weather. What is truly remarkable here is the predictive layer. The AI doesn't just wait and react to the wheels slipping. It anticipates the slip based on how the steering wheel is turned, the position of the accelerator pedal, and the road surface conditions that are picked up by the suspension sensors. If you are approaching a corner at 45 mph, and the system calculates that your current path is likely to cause the front wheels to slide, understeer, HANCBTDT. It preemptively shifts torque to the rear axle before the front wheels even begin to lose grip. This is the difference between simply trying to fix a problem and completely predicting and controlling it. And it's why the Tesla Model 2 feels completely stable and secure in conditions where traditional, budget-friendly electric vehicles feel twitchy and unpredictable. For anyone concerned about their car breaking down, the Model 2's dual motors offer huge peace of mind. Other all-wheel drive electric cars, like the EV6 or Mach-E, are complicated because they still carry a lot of the mechanical history from gasoline cars, including a gearbox for reducing speed and mechanical differentials, which significantly increases the total number of parts, from gears to joints. By relying on software and electronics, Tesla reduces the parts in the dual motor setup to only about 200 moving parts, compared to more than 2,000 in traditional motors. This simplicity reduces the chance of failure by up to 70%. The annual maintenance is expected to cost less than $200, saving drivers $800 to $1,000 compared to older gasoline cars or electric cars with complex all-wheel drive systems. Even if one of the motors were to fail, Tesla's unique fault-tolerant wiring design makes sure the remaining motor continues to work, ensuring drivers are never stranded on the side of the road. While competitors like the 2025 Ford Mustang Mach-E require customers to pay an extra $5,000 to $10,000 to get this level of advanced safety, Tesla is making this premium feature available for average-income families and seniors on fixed incomes. If you could only choose one feature that matters the most in a budget EV, which one would it be? Comment 1 for instant torque and acceleration, 2 for all-weather traction and safety, or 3 for long-term reliability and low maintenance costs. I'm truly curious to hear which aspect is most important to you. Second, we explore the structural battery integration. How does this completely transform the way the vehicle handles in a way that is incredibly beneficial for older drivers, like never before? Along with its dual-motor power, leaked photos of the Model 2 prototype are also sparking a lot of talk because of its incredibly low ground clearance of just 3.7 inches. That is much lower than the Model 3 at 5.5 inches or the Model Y at 6.6 inches. But this small number is not just a style choice. It's definitive proof that, on the new Giga Texas production lines, Tesla has quietly built the Model 2 with a structural battery pack that is built directly into the floor. Conventionally, battery cells are grouped into modules, then packed inside a thick battery box that is typically 4 to 6 inches tall. And that entire box is then bolted underneath the car's frame. But on the Model 2, the structural battery pack is cast as one solid, enormous piece by a powerful 16,000-ton gigapress. Thousands of cylindrical cells are secured in hard epoxy, sandwiched between two strong aluminum sheets, and cast together with the floor structure. By getting rid of all the unnecessary empty space, the floor is much closer to the ground, which is the reason the Model 2 has its striking 3.7 inches of ground clearance. Now, let's discuss what this actually means from a structural engineering standpoint, because this is where Tesla's manufacturing thinking completely breaks away from traditional car construction. In traditional car design, the floor is a separate piece that is welded to the chassis rails, and then the battery pack is bolted underneath as a completely separate unit. The result is 3 separate structural parts, all trying to work together: the chassis, the floor, and the battery enclosure. The Model 2 does away with this entire old way of thinking. The battery is not just mounted to the structure, it is the structure. The aluminum honeycomb that holds the cells doesn't just protect them. It acts as a stressed member that takes on the heavy loads from the suspension and spreads the massive forces from a crash. This is the exact same principle that aerospace engineers use in airplane bodies, where the fuel tanks are actually part of the wing structure itself. The result is an amazing 40% increase in torsional rigidity compared to the Model Y, which was already considered extremely stiff by industry standards. This new design creates a perfectly flat battery floor, which opens up a much more spacious cabin, increasing the interior volume by 15% compared to the Model 3, reaching a massive 110 cubic feet. Given that more than 70% of older adults in the US report having joint or bone issues, this design means much more leg and knee room, helping to relieve pressure on the hips, knees, and spine, encouraging a natural, relaxed sitting posture even on long journeys. However, the most important benefits are in its much more stable operating performance, increased safety, and the resulting boost in driving confidence for seniors. With its tiny 3.7 inches of ground clearance, the car's center of gravity is 18% lower than the Model 3, with the entire heavy battery pack spread out very close to the road. This makes a huge difference in the Model 2's stability. When taking a hard corner at 60 km/h, Typical electric crossovers with around 7 inches of ground clearance will usually experience a body lean of 5 to 6 degrees. In the Model 2, the body lean in that same corner is only about 2.3 degrees, cutting the rollover risk by 22%, according to Tesla's own internal simulations. For older drivers who often have reaction times that are about 15% slower than the average, or who are prone to hand fatigue, this exceptional stability means they don't have to constantly correct the steering wheel when driving on rough roads or in strong crosswinds. There is another consequence of this low center of gravity that doesn't get enough discussion: the polar moment of inertia. Because the Model 2's mass is concentrated in a flat layer near the ground, rather than spread out vertically throughout the vehicle, it requires much less energy to change its rotational direction. In simple terms, this means the car responds much more quickly and predictably to steering inputs. It feels much more agile despite being a relatively heavy electric vehicle. This is the same exact principle that makes mid-engine sports cars feel so responsive. And it's the reason the Model 2 can deliver handling characteristics that you'd normally only find in vehicles in a completely different price category. Even better, the solid aluminum battery pack makes the floor about 40% stiffer than the already strong Model Y. In the event of a crash or heavy impact, the forces are no longer focused on hundreds of weak weld points. They spread out evenly across the entire floor structure. For older passengers who tend to have more fragile bodies, this even distribution of force means much less shock reaches the cabin, protecting their bones and joints significantly better in an emergency situation. Finally, let's address the predictive suspension technology. How can this deliver the smooth ride quality of a luxury car at a tiny fraction of the development cost? The biggest difference between a regular mainstream car and a luxury car isn't just the fancy interior or the badge, it's the actual driving experience and the smoothness of the ride. So, how can Musk make a $25,000 Model 2 provide the same level of comfort as luxury cars that cost 5 times more? Most mainstream cars on the market today, like the Toyota Corolla or Hyundai Elantra, use traditional suspension systems with springs that have a fixed stiffness and shock absorbers with only one level of elasticity. In contrast, the Model 2's adaptive suspension, part of Tesla's 2025 Next-Gen Ride Dynamics technology package, uses shock absorbers fitted with electronically controlled valves and containing hydraulic oil. These advanced components allow them to change their stiffness in just 10 to 20 milliseconds, reacting instantly when the car hits an unexpected surface, based on signals from acceleration sensors, vehicle height sensors, and wheel sensors, all integrated with AI from Tesla's autopilot system. But here is where Tesla's method becomes truly groundbreaking. They are not just reacting to road conditions in real time. They are using the same camera and radar system that powers autopilot to predict what is coming before the wheels ever encounter it. The system analyzes the visual data about 33 feet ahead, correctly identifies any surface bumps or irregularities, and calculates the perfect damping setting before the wheel makes contact. This means the suspension is already in the correct configuration when the wheel reaches the pothole, instead of reacting only after the impact has already started. Furthermore, the AI doesn't just react, it also predicts. It uses data from the cameras, radar, and GPS to scan and analyze the road 10 meters ahead, predict potholes or bad terrain, and adjust the damping stiffness before the wheel even gets close. This capability allows the suspension to actively raise or lower the chassis in just a few seconds, protecting the battery pack and dramatically improving comfort without any extra action from the driver. The difference will be enormous compared to Tesla's earlier models, the Model 3 and Model Y, which can only be adjusted manually and have a noticeable delay of up to 0.5 seconds. In the Model 2, if there is a pothole or a rough patch of road, the AI will predict it and adjust the suspension system 0.1 seconds before the wheel rolls over it. When encountering very bad terrain, the car can automatically raise the chassis by 5 centimeters and soften the springs, reducing cabin vibration by up to 30%. On the highway, this technology works in the opposite direction. When the car's speed goes above 60 mph, the system will lower the chassis by 1.5 inches to reduce wind resistance and, at the same time, stiffen the springs for better grip and control. The result is not only a much more stable Model 2 when cornering, but also a quieter cabin space, with noise reduced by up to 25%, making tire noise virtually disappear. This is exactly the kind of ride quality you usually feel only on top-tier European luxury sedans, similar to the magnetic ride control on the Cadillac Escalade or the adaptive M suspension on the BMW 7 Series. Now, you have a choice to make. Would you rather have an expensive luxury brand badge with older, conventional technology, or cutting-edge engineering and performance in an affordable package? Comment A if the brand name matters more to you, B if the technology and performance are what you truly care about, or C if you think both are equally important. This is going to be an interesting discussion. Tesla, with their brand new 2026 Model 2, is showing us that being affordable doesn't have to mean compromising quality. This car brings together performance, safety, and comfort in ways that have never been seen before at its price point. And when the best Tesla cars are no longer rare luxury icons but common vehicles everywhere, the entire automotive industry will be forced to completely change the way it builds cars. Thanks for diving into this with us, and we'll see you in the next videos. Eat.